James Webb has finally seen it, 7 trillion miles away, and the discovery is shattering everything we thought we knew about the universe. That flicker wasn't supposed to exist, a structured pattern of light, captured by the most powerful telescope ever built, emerging from a planet orbiting a distant star. These weren't stellar flares or sensor glitches. They looked engineered, familiar. Lights that echoed the glow of our own cities, clustered and deliberate, spread across a surface no human has ever touched. It was less like looking through a telescope and more like staring into a mirror from across the stars. The planet in question, Proxima Centauri b, the closest known exoplanet to Earth, a place long suspected to harbor the right conditions for life. But nobody expected this. City-like lights on its dark side. The implications hit immediately. This wasn't just about atmospheres or temperature data anymore. It was about intent, infrastructure, possibly civilization. And the images kept coming. Scientists at NASA, already accustomed to the telescope's almost surreal ability to peer into time itself, found themselves looking at something they weren't prepared for. Not yet. Not like this. David Kipping from Columbia University described Proxima b as complex, not because of its composition, but because of its thermal behavior. Something was bouncing light back in a way that didn't make sense for a dead world. That's where the telescope's true strength kicked in. Unlike older observatories that struggle with dim light, the Webb was built to see what no other machine could. Its sensors, tuned to the far reaches of infrared, weren't just capturing the glow of stars. They were isolating faint traces of warmth from Proxima b's surface, traces that hinted at artificial sources. On the night side of the planet, where the star's light shouldn't reach, something was glowing steadily. Normally, a rocky exoplanet absorbs heat from its host star and radiates it back as infrared. But this one didn't behave like that. Instead, there was a thermal signature that stayed consistent even when the day cycle passed. That didn't align with any known geological or atmospheric phenomenon. It was as if the heat wasn't coming from nature, but from something manufactured. Engineers started asking the questions out loud. How long had those lights been shining before we had the means to notice them? How many years had they gone undetected while we pointed simpler instruments in the wrong direction? The data wasn't static. The frequency was narrow, far narrower than natural starlight, artificially narrow. And that was just the beginning. Proxima b's interaction with its host star, Proxima Centauri, created day and night cycles like those on Earth. But unlike Earth, it might not have an atmosphere, and that changes everything. If there's no atmosphere, temperatures on the planet's surface would swing dramatically between the scalding heat of the day and the freezing cold of the night. But somehow, the thermal profile showed more balance than it should have. That kind of stability usually means one thing: some form of regulation, something deliberate, something intelligent. Scientists began to hypothesize about the planet's energy usage. The daytime side seemed to capture immense amounts of solar energy, potentially using solar panels. If that were the case, then the night side might be lit artificially. That's where the city-like lights came from. An idea that once would have sounded ridiculous was now being discussed in closed-door meetings at NASA and ESA. And while the Webb Telescope was making these discoveries, something else was happening. Its orbital pattern, a seemingly coincidental match with Proxima b's rotation, gave scientists an unprecedented view. Every 11.2 Earth days, it could observe a full cycle. Every turn of that planet brought new data that wasn't declining or fading but holding steady, like a light left on intentionally, like someone waiting to be seen. The next logical step was to look at the planet's atmosphere, if it even had one. That's where the Webb showed its limits. It can detect water vapor, carbon dioxide, and methane. It can infer atmospheric thickness, but detecting bonded oxygen, O2, the real sign of Earth-like biology, is much harder. So, scientists turned to other signatures: ozone, methane, water vapor, gases that don't survive long in atmospheres unless constantly replenished by life or industry. And if those gases, they're detectable in the light that passes through the planet's atmosphere during transit, an incredibly narrow window of opportunity. And Webb caught glimpses of something. Not enough for a declaration, but more than enough to keep the investigation alive. For deeper analysis, researchers are now looking to the extremely large telescope, set to go operational in 2028. It's designed to take this kind of investigation further. For now, all eyes remain on Webb. The machine isn't just capturing data, it's raising questions that our best scientists don't yet know how to answer. To distinguish natural atmospheric processes from artificial ones, they'll need to isolate biosignatures, but biosignatures can be deceiving. Volcanoes can release methane, geysers can simulate water vapor. And yet, even with these caveats, the data points towards something more. Not random, not geological. Consistent, steady, controlled. There's history here too. Humanity has always wondered what lies beyond the sky. In 1984, two American astronomers, Jill Tatar and Thomas Pearson, launched the search for extraterrestrial intelligence, SETI. For over 3 decades, they've scanned the heavens for radio signals. With 42 telescopes pointed at the stars, they hoped for a whisper, a ping, a response. But so far, silence, until now. Not through radio waves, but through light, through presence, through pattern. And the tool that made it possible wasn't even built to find aliens. The Webb Telescope was designed to look backward in time, to glimpse the birth of galaxies. Instead, it may have stumbled upon something alive, something present. The images it's sending back are clearer, sharper, more telling than anything we've seen. Its sensors just pick up visible light. They capture wavelengths our eyes will never. And in those invisible wavelengths, in those dark corners of deep space, something shone through. Scientists now rely on Webb's capabilities to uncover details in planetary atmospheres light years away, to decode chemistry, to piece together physics. Every light signature tells a story. Some reveal temperature, some reveal water. But these latest signals, they hinted at industry, at heat without sun. At night, that isn't dark. The JWST isn't just observing anymore. It's participating. Its tools are designed to search for tiny variations in chemical compositions across vast distances. Variations that, if consistent and organized, suggest artificial processes. And then came the mass discovery. The telescope found more mass in the universe than previously thought, hidden in ancient galaxies. Mass that forced scientists to question their understanding of cosmic formation. If we were wrong about mass, what else were we wrong about? The new data widened the scope, and in widening the scope, it shifted the conversation from "are we alone?" to "what are we looking for?" Signs of life aren't just green plants or flowing rivers. They could be unusual light frequencies, heat that doesn't fluctuate, gases that shouldn't be there, or chemicals like chlorofluorocarbons, CFCs, human-made compounds that have no natural origin. If Webb finds CFCs, that's not a hint, that's confirmation, that's industry, that's civilization. The question becomes, are we equipped to understand what we're seeing? Not all life follows our rules. Extremophiles on Earth live in acid, in heat, in places that should kill anything. Some survive temperatures of 250 degrees Fahrenheit. Others thrive where pH levels drop below 3. Life, it turns out, isn't fragile. It's persistent. And if it can thrive here, it might be thriving in forms we haven't imagined. That's why the search is expanding. Scientists aren't just looking at Earth-like planets anymore. They're studying red dwarfs, small stars that burn dimly and live long. These stars might host planets in the habitable zone for billions of years, long enough for life to evolve, long enough for civilizations to rise. The TRAPPIST-1 system, with 7 rocky planets, is a perfect example. 3 of them orbit within the zone where water could exist. Webb has already begun observing them. And then there's the idea of atmospheres, secondary atmospheres, the kind Earth developed after its violent beginnings. For the first time, with Webb, we can actually search for those in other worlds. It's what surrounds a planet, but what stays there, what breathes, what recycles. Ward Howard, a NASA Sagan Fellow, says this is the breakthrough. This is how we stop guessing and start understanding. But amid all these new targets, Proxima Centauri stands apart. It's close, just 4.25 light-years away, the closest star to our sun. And in 2016, we discovered a planet circling it, Proxima b, a world 1.3 times Earth's mass, located perfectly in the habitable zone. But there's a catch. It orbits just 4.6 million miles from its star, exposed to intense solar radiation, winds that could strip away its atmosphere, heat that could sterilize its surface. and yet it receives just enough light to keep water in a liquid state, enough energy to sustain chemistry, enough balance to spark the impossible. The planet is likely tidally locked, one face always basking in light, the other trapped in darkness, a perfect split of eternal day and endless night. And somewhere in that twilight zone, the Webb Telescope found a glow, a pulse, a signal. Even now, the data is still being studied, frame by frame, wavelength by wavelength. What we thought was a silent, rocky world might be something else entirely. Not just a planet in the habitable zone, but one already alive, already illuminated, already signaling. And the more they analyze, the more deliberate it looks. Not the result of flares or thermal anomalies, not reflections or faulty measurement, but a constant pattern, a glow that holds. Engineers have checked and rechecked their instruments, cross-referenced with other observatories. Nothing explains it naturally, and that leaves only one option. Something intelligent, something there. If it's true, it would be the closest evidence of extraterrestrial life ever detected. Not a whisper across centuries, but a light in the dark. A light someone might have left on, hoping one day we'd see it. And now that we have, the question is simple: what do we do next? Because if we're right, this isn't just a discovery, it's an answer. One we weren't supposed to find so soon, and maybe that's why it was hidden in the dark. The information presented in this video is based on available insights and may include elements of interpretation, speculation, or unverified sources. Thanks for watching, and we'll catch you in the next one.